Find the linear approximation for the function f of x equals x times the square root of 20 minus x squared at a equals 2. Then use the result to approximate f of 2.05 and f of 1.91. The linear approximation involves the function f of x, which is x times the square root of 20 minus x squared, as well as its derivative. But before we take the derivative, let's rewrite the radical as a fractional exponent. So it'll be 20 minus x squared to the first power second root 1/2 power. The derivative, f prime of x, will involve the product rule. The derivative of the first, the derivative of x, is a 1 times the second left alone, 20 minus x squared to the positive 1/2, plus the first left alone, x, times the derivative of the second, which will be a power rule. Bring down the power, leave the inside alone, subtract 1 from the power, I will call that 2/2, and then multiply by the derivative of the inside to complete the chain rule. The derivative of 20 is 0, the derivative of negative x squared is negative 2x. This will then give the first term 1 times 20 minus x squared to the 1/2 will be 20 minus x squared to the 1/2. The second term will have the negative 2 can move out front and multiply with the 1/2. Negative 2 times 1/2 is negative 1. And then the x can multiply with the x. Everything's multiplied here, so the order can be moved around. And overall, this will give negative x squared, and then times 20 minus x squared to the 1 minus 2 negative 1/2 power. So f prime of x equals the first term, we have the quantity to the 1/2, and that can be replaced with square root of 20 minus x squared. The second term, we have an x squared, but then we have a negative exponent. It can move to the denominator to become a positive exponent. And it'll be 20 minus x squared to the positive 1/2, which can also be replaced with a square root. Of the 20 minus x squared. The next thing to do is evaluate the function f of x at the a value, which is a 2. So f of 2, which is going to be 2 times the square root of 20 minus 2 squared, which will be 2 times the square root of 20 minus 2 squared is a 4. The minus is not part of the square. And that'll give 2 times 20 minus 4, which is 16, under the square root. The square root of 16 is a 4, giving 2 times 4, which is an 8. And also evaluate f prime at the a value of 2, so f prime of 2, which will be the square root of 20 minus 2 squared minus 2 squared over the square root of 20 minus 2 squared. 2 squared is a 4. So everywhere we see a 2 squared, we can put a 4. It's happening in 3 different locations. So the square root of 20 minus 4, which is 16, minus 4 over the square root of 20 minus 4, which again is a 16. The square root of 16 is a 4, so we have 4 minus 4 over 4. 4 over 4 can reduce to a 1, so we have 4 minus 1, which is a 3. The formula for the linear approximation is f of a plus f prime of a times x minus a. In this problem, a is a 2, so this will be f of 2 plus f prime of 2 times x minus 2. We have values for f of 2 and f prime of 2. Those can now go into place into the linear approximation, giving 8 plus 3 times x minus 2. To simplify, the 3 can distribute in here, giving 8 plus 3x minus 6, and then the constants can combine together, giving 3x plus 2. The next thing to do is to use this to approximate f of 2.05. The linear approximation can approximate f at any value that's near 2. 2.05 is near 2. So this will be able to be approximated by plugging the 2.05 into L. The best version to use numerically is usually the original version, this one, which will give us 8 plus 3 times 2.05 minus 2, which is 8 plus 3 times 2.05 minus 2 is 0.05, which gives 8 plus 3 times 0.05 is 0.15, and this comes out to 8.15. F of 1.91 can also be approximated with this linearization. Using the same version, we'll give 8 plus 3 times 1.91 minus 2, which will be 8 plus 3 times 1.91 minus 2 is negative 0.09, giving 8. A positive 3 times a negative 0.09 will be a negative 0.27. 8 minus 0.27 comes out to 7.73.